I'm going to work through the first 24 problems of the study guide for your second semester final. This will include the mathematical way to work through the problems, not necessarily the ACT types multiple choice strategies that we talk about in class. Okay, so for number one, they're telling us that we have a translation. It's going from ABCD to A prime, B prime, C prime. The easiest way to get this one to see what happens, we're looking for where the coordinates X, Y go to. The easiest way is to count. Pick a point, for example, D. Notice that every line is counting by twos, and we're going to count up to D prime. So first I'm going to see how far it moves left or right, because that is the X. So 1, 2, 3, I move 3 steps to the left. So that means each X is being reduced by 3, so X minus 3. And then for the Y's, we're going to count up 1, 2, 3, 4, 5, 6. So each Y is going up by 6, so it's Y plus 6. Number 2, they said describe the transformation. We've had studied translations, which are shifts, rotations, which are pivots, turns, and then reflections. Reflection means it's being flipped over an axis of some sort. Since the triangle is changing position, and in fact, if you look at XZ, it's going from being upright to on its side. That is a 90-degree switch. It turns out that this is a 90-degree rotation clockwise. An easy way to see this is to draw a line from the origin to Y and to Y prime, and what you're going to see is a 90-degree angle. And it'll work that way if you draw a line from Z to the origin and then to Z prime, you'll also see a 90-degree angle in there. So that tells us that we are rotating 90 degrees. Number 3, we're going for midpoint. I already have this one worked out a little bit. Midpoint is middle point. So we're going to average the X's, -3 plus -9, and divide by 2. You'll get -6. And then average the Y's, 15 plus 5 divided by 2, and we get 10. And you will graph it out either X and Y individually on a number line. You'll see that -610 is right smack in the middle between those 2 points that are given. Or you can graph it on an XY coordinate plane to show yourself that that is the midpoint. Number 4 is all about definitions. Make sure you know these numbers. Congruent, 2 angles are congruent. It means they have the same angle measure. 2 segments that are congruent have the same length. Supplementary means that the 2 angles add up to be 180 degrees, as opposed to complementary, which means their sum is 90. 2 lines are perpendicular if they make a 90-degree angle. A polygon is a many-sided figure in a plane, so like a triangle, a rectangle, a square, a hexagon, a pentagon. Main thing is it is a flat figure. It has length and width. A circle is a set of all points in a plane. Again, a flat surface, and those points are all equidistant from a single point called the center. And that distance that you're measuring out is a radius. Proportion is 2 fractions that are equal, set equal to each other. Sometimes we have variables in them, sometimes we do not, but it has to be a true statement. In number 5 and 6, we're using some of those definitions to answer a question. Number 5, we need to write a conclusion. 2 angles are supplementary if their sum is 180. So the conclusion is that their sum is 180. In the transitive property, it says if a first quantity equals a second and that second equals a third, then the first and the third are equal. So we have the measure of angle 1 plus 2 is equal to the measures of angles 3 plus 4. Starting with number 7, we begin talking about parallel lines cut by a transversal. Number 7, which of the following statement is needed to prove that the angles are parallel or the lines are parallel? 3 and 6 are vertical angles, so that is not it. 1 and 2, they're a linear pair. They're supplementary. And angles 2 and 3 are not alternate interior, alternate exterior, or corresponding. In fact, angles 2 and 5 are alternate exterior angles. So those are our answers. Answer C. Number 8, we're trying to prove that 2 and 6 are congruent. They are corresponding angles. So that would be the corresponding angles theorem. None of those other possibilities use the names corresponding angles. Number 9, we have 2 lines parallel, L and M, and we want to find the value of x that makes those lines parallel. Well, the 2 angles there are alternate interior angles, so we can set those 2 measurements equal to each other, because for alternate interior angles they would be equal, and solve that equation. Divide both sides by 3, and we get x is 62 degrees. That would be our answer. Which statement proves that M and N are parallel? That would be number 6 for alternate interior angles. 1 and 4 are vertical angles, has nothing to do with the lines being parallel. 2 and 4 are a linear pair. 5 and 7 are supplementary. The only answer that deals with both lines, an angle next to both lines, is 3 is congruent to 6. And that is true because they are alternate interior angles. Number 11, the answer is 11. We're given that AE is 6, is 10, and that D is the midpoint. So each part of that is 5. We're wanting to know what the length of A to D is. So if you take 6 plus 5, you get 11. Number 12, write an equation of a line parallel to the one given through the point. The old math teacher way says to use the slope-intercept form, so y minus the y coordinate is equal to the slope times x minus x coordinate. If we simplify the double negatives, you get y plus 3. Distribute the negative 1/4. Negative 1/4 times 8 is 8 over 4, or 2. And then subtract the 3 from both sides. We get y equals negative 1/4 x minus 1. Number 13, what is the slope of the line perpendicular to negative 3/2? The slope of this line is negative 3/2. So perpendicular, you would change the sign to positive and flip that slope to 2/3. Number 14, we have the names of 2 figures that are congruent. So if you match up the letters in the corresponding positions, you will have corresponding segments. Number 15, again, 2 triangles that are congruent. We want to find the length of QS. It is in a corresponding position with TV, so that means QS is congruent to TV. Subtract 3V from both sides of that equation to solve. You get 2 equals 4V minus 6. Add the 6 to both sides and divide both sides by 4. We get V equals 2. They didn't ask us for V, they asked us for the lengths of those segments. So plug that 2 in, and we get 6 plus 2, or 8. Number 16 is where we start talking about congruent triangles. That is, if you recall, we had theorems on SSS, side, 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 angle, side, angle, side, angle, 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 side, all the ones listed there. So if you look at your picture, we have one pair of sides marked congruent, we have a right angle, and then we have a shared side. And as you walk around that triangle, that is a side followed by an angle followed by a side. So we have SAS. Number 17, everything is already marked. If you walk around the figure, you have an A followed by an S followed by an A. So ASA. Number 18, they want to know what additional fact, and they're telling us we've got to use AAS. So we have one angle marked. We have a shared side. So what we're missing is an angle, and it has to be next to the other angle without the side in between. So that means we have to go from D to A to the side, so AAS, and B, angle, angle, side. So angle B is congruent to angle D. Next page starts with number 19. We're still dealing with congruent figures. This time 2 pentagons, but we're still going to match up the corresponding positions. They give us the name, so we can match things up. X is over here at angle T, so it corresponds to angle E, so our equation is 2x plus 10 equals 110. Subtract 10 from both sides of the equation, divide both sides by 2, and we get x equals 50 degrees. We now progress from congruent figures to similar figures. Similar figures have congruent corresponding angles, sides that are proportional. So if we match up the sides, small figure over large figure, we'd have 12 over 24. And then small figure over large figure. And it can be that way, or both fractions can be upside down. Make sure that when you think you have the right answer, you do simplify those fractions. They should both reduce down to the same number and be a true statement, which this one is. 21 is also using similarity, this time with triangles. They tell us that the two are similar. Write a proportion. I'm going to write a proportion that uses the small triangle over the large triangle. So pick either side. I'm going to start with a 10 and match it over the corresponding side of the other triangle, 10 over 12, and then the second pair, 15 over 18. You'll know that's a true statement if we check it. 2 goes into 10 and into 12. 3 goes into 15 and into 18. They should reduce down to the same number, so we know we have the right answer. Number 22 is still dealing with similar figures. This time we have 2 triangles, and if you read that, the statement or the story, you'll realize that you do have 2 similar triangles. We're trying to find the length across the lake, so I've marked it X. And then as I look at my triangles, I notice that each of them has a short side and a long side, and the triangle on the left is short side and long side. And so I'm going to set up my proportions so I have the triangle on the right over the triangle on the left. So let's start with the X. X corresponds to the 47. And then you can pick either one of the other 2 sides on the right-hand triangle. I'm going to go with the short side, which means it corresponds to the short side of the triangle on the left. That would be the 82. To solve a proportion, you cross multiply. So 82x equals 47 times 73.8. I don't have a calculator, so I'm not going to go ahead and punch it. But after you would get that product, you would divide both sides by 82. And we would get, for an answer, 42.3 meters. Number 23 is also using similar figures. We're looking for the height of the tree in this one. I have a small triangle and a large triangle, if you look at the picture. So that's how I'll set up my proportions. All right, X is the height of the tree, and it corresponds to the 160. You could use either the 120 or the 144. Doesn't matter. On the small triangle, I'm going to use the 120. And then I need the corresponding side on the large triangle. If one double hash mark is 120, the other one is also, which means the whole side is 240. Before I cross multiply, let me do some reducing. And then cross multiply. 2x equals 160. Divide both sides by 2, x equals 80 feet. And then finally, number 24, the last one on this video. Again, similar triangles. This way, we can work this one slightly differently because we're told that the two sides are parallel. And if you remember, we had something called a side splitter theorem. And it said if two lines are parallel, that it splits those transversals, the two sides of the triangle, into proportional sides. So on the left side, the bottom over the top parts is equal in the same ratio as the bottom over the top parts of the right one. And if we cross multiply, 64, 44, divide both sides by 12, we get x equals 12. If you didn't remember that, then you could do small triangle over large triangle equals small triangle over 12 plus 18 is 30, and solve that. You will still get x equals 12. There'll be a second video posted tomorrow with the rest of the problems.